All right, this video covers how to find the surface area of pyramids and of cones. So a pyramid, as we know, has one base, and then it also has some lateral faces that meet at a vertex, and all those lateral faces are triangles. So in this case, we also have slant height that we're going to need to use in order to find the surface area of a pyramid. That's the height of one of these triangles, one of the lateral faces. So if we take halfway between C and D and we measure up to A, that would be a slant height. We'll see an example of that in a little bit. Here we've got a base, it's this square, B, C, D, E, and then we've got four lateral faces, the triangles. Okay, so if we want to find the surface area of a pyramid, we have the following formula. Surface area equals B plus 1/2 perimeter times the slant height. So B is the area of the base, the square down here. It's not always going to be a square, but it's going to be some shape. P is the perimeter of that base. And then L is the slant height. So that's this dotted line here from the middle of one of these lateral faces all the way up to the vertex. So let's use this to find the area of this pyramid. So here's a reminder of our formula. B equals 1/2 PL. In this case, our base is a pentagon. We know that our perimeter would just be 80 because we have 16 per side of this pentagon. So 16 times 5 gives us 80 for our perimeter. And we know our slant height is 10. So we've got P and L, but we don't have B yet. We got to find B, but we can do that because this is a regular pentagon. So we can use our formula to find the area of that regular pentagon. We do 1/2 the apothem times the perimeter, and we get 440. So then to find our surface area, we just need to plug these three values we found into our formula. B plus 1/2 PL, and we end up getting 840 inches squared. All right. Next one, we want to find the surface area of the pyramid. This time our base is a square. And also we have a height of 12 inches, not a slant height, but just a height from the middle of the pyramid up to the top. So in this case, we actually are going to have to find the slant height ourselves because we don't know the slant height yet. So again, here's our formula. We know our perimeter is 40. And that makes our base 100 because it's a square, just 10 times 10. But like I said, we have to find that slant height. We don't know that slant height. So let's draw a triangle and solve for the hypotenuse, right? We've got 12 as the height here. Each of these sides is 10, which means this is 5. It's halfway to get to this center of the base. So we have a 12 and a 5, and we need to figure out what the slant height is. So we're going to use the Pythagorean theorem. And we solve for that slant height and we get 13 inches. So now we have everything. We can just plug it right into our formula, B plus 1/2 PL, and we get an answer of 360 inches squared. All right, let's keep going. Let's talk about cones. So a cone, we've got a base that's a circle and a vertex. Our formula is the following. Pi r squared plus pi rl, where r is the radius of the base and L is the slant height. So again, our slant height is this height right here. Sometimes we'll be given it, sometimes we'll be given the height this way, and we'll have to solve it using the Pythagorean theorem, just like we saw before. All right, but let's do this one. So we got our formula. Pi r squared plus pi rl. We need to think about what is the radius and what is the slant height. Well, our radius is going to be 14 because our diameter is 28. Our radius is half the diameter, and our slant height was given to us. It was 50. So then we just plug that into our formula. We can write our answer in terms of pi or as an approximate answer. All right, and one more example. Here we are given a radius. And here we are not given the slant height, and we're going to need to find it. We have the measurement of just the regular height of this cone. We need to find the slant height. So again, we're going to use the Pythagorean theorem. We've got our formula. We know our radius. we're going to solve for the slant height. That gives us 35 for that slant height. So we got a radius of 21, a slant height of 35. We plug into our formula, and again, we can write our answer in terms of pi or as an approximate answer.